What's going on, everybody? Welcome back to another MCAT Mondays, Gen Chem episode number 9. Today we're going to be talking about thermodynamics. Alright? Careful, because you just might get burned. Oh! Alright, so yeah, we're going to be talking about thermodynamics. Alright? So, first up on the agenda is talking about the laws of thermodynamics. But wait, there's laws in chemistry? Well, yeah, for you kids there are. But on this show, on this video broadcasting platform, I am God, alright? Don't believe me? Check it. See that? Pretty wild. Alright, so physics doesn't apply to me on here. Don't hate the player, hate the game. But yeah, alright, so we got thermodynamics on here. Specifically, we got a couple laws of thermodynamics. Alright? So, now this is going to be wild, right? You guys are going to be thinking the first law of thermodynamics would be called the first law, right? Nah, homies, you guys are wrong, alright? Ladies and gentlemen, it's called the Zeroth Law of thermodynamics. What? You forgot about the Zeroth Law? Plebeians, am I right? Zeroth Law. Look at that. How are you going to forget zero, man? Huh? Always put some respect on this boy. Alright, so, Zeroth Law of thermodynamics. Now what this means is that there's thermal equilibrium. Okay, so let's just say you have three systems. Let's just say A, B, and C. And let's just say A is in thermal equilibrium to B, and B is in thermal equilibrium to C, and what can you tell from this? If A is in thermal equilibrium to B and B is thermal equilibrium to C, that means intuitively that A must also be the thermal equilibrium to C. Right? Pretty wild. I bet you guys couldn't guess that. Especially since you probably never heard of this formula. A equals to B, B equals to C, A must be equal to C. Right? Pretty easy stuff, but I guess, you know, it wasn't easy back then. So yeah. So that's what's thermal equal. This was the Zeroth Law. Is that so? Like if you have systems that are in thermal equilibrium to each other, you have three systems that are thermal equilibrium to each other. A is thermal equilibrium to B, B is to C. A would also be in equilibrium to C as well. Right? Wild. I know. Cutting edge stuff. But yeah, this is the Zeroth Law, and it's pretty important for the MCAT. I don't know. I think I've seen a few questions about like. There's definitely some thermodynamic questions on there, but yeah, just remember that. As well as there's thermal equilibrium, which means having the same thermal energy as one another. So yeah, they have the same thermal energy as one another. That's why it's called equilibrium, thermal equilibrium. Yeah, pretty wild. And yeah, so this is actually a measurement of. There's two terms here that you should know. Heat, which is the actual description of the thermal energy. So when you're saying heat, that's the thermal energy that's involved. Versus temperature, all right? If you guys mess this up, I swear I'm going to contact your parents, all right? And let them deal with whatever your shenanigans are, okay? Okay. So yeah, heat is thermal energy. Temperature, all right? If you fools mess this up, man, I don't know what else to say. Contacting your parents, all right? temperature. Okay? Temperature is not the same thing as heat. Alright? Temperature measures the kinetic energy of the molecules in the system. So yeah, basically how fast the molecule is what the temperature is. Temperature gives you an idea of heat, the thermal energy, gives you an idea of the thermal energy, but it's not actually the thermal energy. It's just talking about the kinetic energy of the molecules involved. Yeah, pretty wild stuff. So yeah, that's the Zeroth Law, my friends. What am I, a lawyer? Well, for today, yes, I am. Okay. Legal practices. Don't actually ask me for legal advice. Contact my friend Henry the lawyer. Harry Hyder, whatever the dude's name is. But yeah, not really my friend. I don't like that guy. But yeah. Okay, so yeah, there's also the first law of thermodynamics. Alright. This one basically says same thing as like the energy conservation, the law of energy conservation. Energy can't be created or destroyed, but they can be transferred. So talking about transferring of energy. Transferring energy only. Can't be created or destroyed. Yeah, unless you're me again, because I am God on this show, okay? Alright? So, a couple more terms for this one. This is specifically for the system involved. Maybe cannot be created or destroyed. You got an isolated system. Alright? Now this system is like, I don't like you, energy, get away from me. Alright? Nothing can pass. I got all my energy that I need. You can't have any to another system or surrounding. Just like, yo, I'm gonna mess you up if you touch me and harass me, you know? So basically it has constant energy. Remember that. No change in energy. Alright? You won't lose any energy, you won't gain any energy. It's basically like, yo, I'll square up with you if you touch me. Okay? So that's what an isolated system is. Now, for systems that are not in isolation, there are two different ways of how they gain and lose energy. Or basically the same thing. So a system gains energy from the surroundings, from its surroundings. Two separate terms, alright? So let's just say that this is a system and the surroundings are all this garbage right here, alright? So if work is being done onto the system, that means it's going to gain energy, alright? But if a system is doing work onto the surroundings, it's going to lose energy, okay? So yeah, it can either gain energy from the surroundings or lose energy by doing work to the surroundings. And there's a popular formula for this. This is U, which denotes internal energy of the system, equals Q, which is the heat added, or the heat of the system, plus or minus W, and that depends if the system is doing work or the surroundings are doing work. Pretty wild, right? Bet you guys didn't know that math was involved in chemistry. If you guys did, then you know you're probably one step ahead. Alright, so that basically covers the laws of thermodynamics that I'm going to be teaching for right now, because these two are the most important for the MCAT. The other two I'll give at the very end of this because hey, it's pretty useful to know anyways if you're a chemist, alright? But yeah. Okay, so next up, I'm going to be talking to you about, so So yeah, enthalpy, right? Right? Is that where we left it? Yeah, enthalpy. Okay. Enthalpy is the heat energy, the thermal energy of the bonds in a molecule. All right. So yeah, let me just write that down. So yeah, thermal energy stored in a chemical bond, right? Remember how we just went over bonding in the last few slides or lectures? Yeah, this is the thermal energy stored in a chemical bond. Okay, and pretty cool stuff. You got here, let's see, common things here. Enthalpy is termed as H, or delta H, which is the change in enthalpy. If the change in enthalpy is less than 0, it's exothermic. Exothermic, man, what does that mean? Exothermic means like explosions. Think about explosions. Exothermic explosion, boom. You know, like that. Endothermic means adding energy into the system. Yeah. You know, just think about like adding energy so the system, the surroundings getting colder or something like that. Yeah. Yeah. When bonds, so yeah. So this is endothermic, this is exothermic. And so yeah, heat is released from the bonds. Heat is released from bond formation. From bond formation. Okay? Bond formation. This is bond formation, this is breaking of bonds. Alright, so let's think about it this way. I don't know why my voice cracked. But yeah, putting in energy into a bond, right? You're putting in energy, right? How I was talking about putting energy into this bond. You gotta break it in half, right? It's gonna take a lot of energy to do something like that, because you got like, just think about like a bone snapping, and I don't know why I said that, but like think about like breaking a stick, right? You gotta put in some work into that, okay? But if you're forming a bond, right, that's actually releasing heat, because like, you know, you're colliding some stuff into each other and like that, releasing of heat. So yeah, heat is released when bond is formed, and when bonds are broken, you need energy input. Okay. So, I got a live demo for you guys, but like, I'll show you an example of an endothermic and exothermic graph. All right. Got endothermic right here versus exothermic. And then you got little graphs right here, time right here. Time, the enemy of all things good. Yeah, enthalpy right here, right? See here, endothermic, you got reactants on the bottom and products on the top, so P, R, and you also have, for exothermic, reactants on the top and products on the bottom, right? Look at that. Look at the difference between the two. One's going up, showing an increase in energy needed to create these products, and one's going down, you know, like a roller coaster. You know, up and down. And that's an increase of delta H, decrease of delta H. So yeah, that's basically that, and I'll show you this live demo if you guys didn't get it before. All right, change perspectives. Okay, just change in perspective, boys. Look at that, wild stuff, family, mi familia. But yeah, it's currently 2 in the morning. My eyes are bloodshot, but here's the demo in my high-tech, sophisticated lab. I don't know how to flip this camera. Let me see. Do you double tap? No, that's changing the brightness. How do you switch this? What is going on here? Can you not switch in between? Can't zoom in that or out this mode. Is it this one? I just took a picture. Alright, we're having technical difficulties. Please help. Mom. So it appears that I can't actually change the camera mode on this stupid phone, but yeah, here's my high-tech demo, okay? You got this ball right here. Alright, you got reactants on this side, products on this side. Now this is an endothermic reaction, right? Look at that. The ball doesn't go up, right? You see that? Why? Why is that so? Because, you know, you gotta have to put in some work in here, right? You gotta put in that energy to break that bond. Look at that. High tech, sophisticated. Alright, now, now look at this, watch this, guys. Whoosh, magic. Magic in the making. Don't judge this, okay? Magic in the making. Look at that. Exothermic, guys, exothermic. Watch this. Boom, look at that. No energy added. It's almost as if it worked on itself on this workout machine that I'm calling my demonstration. So yeah, I gotta flip this back now, so I'm gonna have to stop this right here. Wait, did I? Okay. Yeah, so yeah, that's basically it. It's your boy T. This is MCAT Mondays, Thermodynamics. If you want me to explain anything more, you know, I got you. Yeah, just let me know. Yeah, it's 2 in the morning. I'm gonna go sleep. And yeah. Good night, guys.